Ciao, ladies and gentlemen. So I got this question sent in using approximations to one significant figure. So I'm just going to underline that. Estimate the value of, and you got the sum there. So estimating any calculation that involves estimating and you are told some form of rounding like this, or if you're basically looking at a bunch of sums going on here with decimals, effectively what you have to do is round every number to one sig fig. So we do that by taking all of the numbers that are involved one at a time. So we have 0.482, 61.2, and 98.01. Now I'm going to start with the middle one because it's the easiest one to round. So this 61.2, the first significant figure is that 6 at the start. So we're going to round after that. That 6 followed by a 1 is going to leave us with a 6 followed by a 0. And then our point we put in there as well. So we're going to remember that when we round that 6, it'll become a 60. Second one I'm going to do is the last one, 98.01. So after that 9 is the first significant figure. Followed by an 8 is going to turn that into a 10. Followed by a 0 signifying that digit there being rounded. So that, if I draw the dashed line in again, that's an easier way of seeing that this 9 turned into a 10 effectively, or this 98 got rounded up to 100. That gives us 100. And lastly, we have 0.42. Now this one, that is not the first significant figure. It is not the first figure of significance. You're looking for the first digit that's not a 0. So the 4 here is the 4/10. That's going to be our first significant figure. Therefore, we do the rounding between it and the 8. So that 4 followed by an 8 is going to leave us with a 5 followed by a 0. Now, in this case, we don't technically need to write that 0 in the end because the point's here at the start. But I'm going to be honest, if you did write it in, it's not the worst thing you could do because people can forget sometimes to put these zeros in here. So putting in too many zeros is not really a bad thing. Of course, we've got the 0 beforehand, before the decimal point as well. So the three numbers we're going to be using in the sum are 0.5, I'll just get rid of that now, 60, and 100. So our sum looks like this, 0.5 times 60 squared all over square root of 100. And now we just got to follow BODMAS rules and simplify this one step at a time. Powers and roots, whichever one of those you choose to do first, it's up to yourself. I'll do the square root of 100 because it's the easy one to begin with, so we end up with over 10. We're then going to have 60 squared. 60 times 60 is the same as 6 times 6 with 2 zeros in the end, effectively, or 2 10s being times together after that. So we end up with 3,600. 0.5 not done anything with yet, but 0.5 times something is the same as halving it. So half of 3,600 is 1,800 over 10, and then that becomes 180. Now that could be the answer to it. That's technically an approximation for sure, but it might be possible. I know this question's from an online platform. It could be that at this stage here, they don't want you to find half of 3,600. They might want you to round that again. So anytime you have a number that has more than one significant figure in it, it could expect you to round that. So 3,600 to one significant figure gives us 4,000. Then when you do half of 4,000, you get 2,000. And then when you've got that over 10 to deal with now, 2,000 over 10 ends up equaling 200. So technically 180 is a better approximation for our answer, but it might be that this online platform 200 might be the answer they're looking for. Either way, they're both approximations. They're both perfectly correct. Hope that helps.